Okay, so today we're learning our fourth method for solving systems. This one is the method of elimination. This is my favorite of the four because it tends to go the quickest. At least the initial step goes the quickest. So here's the big idea. You are allowed to, if you have two equations that are set up and they're lined up like these, see all the x's and the y's and the equal signs are all lined up. If that's the case, you are allowed to add the two equations together. We're just going to add going straight down. Let me zoom in a little bit here. Other way. All right. Oh, come on. So you guys can see your sheet. What's going to happen when I add negative 2x, and this is a negative 1x. I'm going to put that one in there. Negative 2x and negative 1x, when I add those together, I'm going to get what? Negative 3x. What's going to happen when I add negative 6y and positive 6y? They're opposites, so they're going to eliminate, and it's 0. I'm not going to bother writing anything in there. I'm just going to cross them out. They eliminated. That's why this is called elimination. And then 0 plus negative 27 is just negative 27. So there's our first step. Do you think you'd be able to solve that for x pretty easily? Let's do it. Let's solve for x. Should just take us one step here. We got negative 3 multiplying by the x, so let's divide by negative 3 on both sides. We're just going to get a 1x equals negative over a negative is going to give us a positive answer. 27 divided by 3 is 9. That's it. Isn't that awesome? It's like the quickest first step of systems we've done so far, right? Now the trade-off is the second step's a little bit longer than what we've been dealing with, but you guys got this. How do you suppose we're going to solve for y? We only have half of our solution right now. How do you suppose we're going to solve for y? Any guesses? How have we been solving for our missing variable so far? Yeah, we take this 9 that we just got, we're going to put it back into one of these original equations, and then we'll solve for our other variable. So your choice, which one looks friendlier to you, the top one or bottom one? There's no wrong choice here. You guys like the top one or the bottom one? What do you think here? Top one. I like top one too. It's got a 0 in it. Zeros are usually pretty friendly, right? So let's write it out. I'm going to rewrite it. I'm going to leave the x out, though, because I know what x is. So negative 2x minus 6y equals 0. And we'll stick that 9 in there, since we know that x is 9 now. And then we can solve that. Let's simplify this a little. Negative 2 times 9, that's negative 18. Minus 6y equals 0. And we're going to work on this side, trying to get y by itself. I'm going to say, let's get rid of that minus 18 first. We'll do plus 18 on both sides. Now I got negative 6y equals 18. And one more step to get y by itself. We'll divide by negative 6. And we'll get y equals negative 3. So we got our x, we got our y. Our final solution then would be, let's see, I want my x first and then my y. So 9 comma negative 3. And that is elimination. Let's do one more together, and then I'm going to challenge you guys to knock out a couple. Question?
Mr. Height,
yes?
Are these students learning anything about modifying an equation today?
Yes.
How about that?
Yes. Second half. Second half. All right, number 2. Let's add them. Let's add them going straight down. I got negative 3x and positive 3x. When we add those, they are going to eliminate. Gone. 4y and 10y, that is 14y, equals 15 and 27. Someone help me out here. What's 15 and 27? 42? Thank you. So we got 14y equals the 42. That's a nice simple equation. We'll solve that. Let's divide by 14 on both sides. Y equals, I want to say that's 3. Can someone confirm that for me, please? Thank you very much. So we got half of our answer. That was the easy half. We're going to need to come back and solve for x now. So we already solved for y, so we're going to need to come back and solve for x. So which one looks friendlier to you, the top or the bottom? No wrong answer here. Bottom one's got bigger numbers, but the top one's got a negative in it. Which one do you want? Top or bottom? Lena, which one are you thinking, top or bottom? Just flip a coin if you're not. The bottom one? Good choice, good choice. There is no wrong answer. This is just a preference thing. And then if somebody else wants to go for the top instead, you can use the top. You'll get the same answer that we're going to get. I want the bottom one. All right, I'm going to leave my y out because I know what y is this time. So 3x plus 10y, but I'm leaving the y out, equals 27. And I left the y out because I know what y is. Y is 3. So we got 3x plus 30 equals 27. Y'all know how to solve that. Get that x by itself. I think I'm going to start with the 30. Minus 30 on both sides. I think that's going to get us... oops, why did I make that negative? I was thinking about the other side. 27 minus 30, that's going to get us a negative answer, right? Negative 3. And then we'll divide by 3 on both sides. Get x equals negative 1. So our final answer solution is negative 1 comma 3, and that's our second one. All right, my challenge to you right now, there's 4 problems down at the bottom of the page. See how many of those you can get done. I am not going to give you enough time to get all 4 of them done. Okay, I'm only going to give you about 5 minutes here. But see how many you can get through. I'll get you some answers to check against here. If this is giving you any trouble at all, if you're not sure what's going on, get my attention. I'll sit down and work with you. All right, we'll come back together in about 5-6 minutes. See how we did. All right, go ahead and pause wherever you're at right there. Check the ones that you got. Number 5 was kind of, I anticipated that might have made some of us feel a little uncomfortable. I know a lot of people don't like it when you get a 0 on one side of your equation, but that's okay. 0 is a number. It's a viable number. Anybody have any questions so far? All right, so we're going to flip the page over in a second, but before we do, I want you to notice something about all of these problems. Well, actually, why don't we do this? Why don't we flip the page over and I'll ask you what's different about the problems on the next page. All of these have something in common that none of the problems have on the next page. Show you our next page here. What's different about the problems that you see on the next page? What are you noticing? Once the thing focuses. What's different? When we do our first step, is anything going to eliminate on this page? Look at this problem. When I add these together, are my x's or my y's going to go away? No. And that's a problem. The reason that these problems worked for us was because in the first step, you always had either the x's or sometimes the y's were canceling each other out and eliminating. Okay, that's got to happen in order for this method to work. That's why it's called elimination. That's not going to happen here. My x's aren't going to match up and eliminate, neither are my y's. All right, so we got to do one extra step here, and this isn't terribly difficult, but this is what kind of raises it up a level. You guys with me? Please don't miss this. Can you turn the page over, please? Thank you. So this is kind of the key piece. I kind of started you off with the ones where they were already set up to eliminate. It's usually not going to be that way. All right, so here's the deal. I'm allowed to modify this problem. This is what Mr. Sweats was just asking about. He was asking if we were going to modify the problem. I'm allowed to modify this problem, and the way I can do it is I can pick one equation, or both if I want, and I can multiply everything in that equation by any number that I want. I'm allowed to do that. Okay, that's one of the rules of algebra. As long as I do the same thing throughout the entire equation, I'm allowed to do it. So I want you guys to focus on my x's right here. And my question to you is, can you think of a number that I could multiply this entire equation by so that my x's would eliminate? Right now I got a positive 6x and a negative 12x. The negative 12x and the positive 6x are not going to eliminate. But if I could somehow make this 6x into a 12x, it would eliminate. Agreed? What would I need to multiply that 6x by to turn it into a 12x? I would multiply it by a 2. That would turn it into a positive 6x, right? Which would cancel with this negative 6x. Let's rewrite these equations off to the side here. Now, when I multiply by 2, I got to multiply everything in the equation by 2, including this negative 12 over here. So let's do this. 2 times 6x is 12x. 2 times 6y is 12y equals 2 times negative 12 is negative 24. The bottom equation stays the same, so just bring it right over exactly as it is. Negative 12x plus 5y equals negative 27. All right, so what you missed if you weren't here was these weren't set up to eliminate to begin with, but we decided if we multiplied the top equation by 2, we could get the 12x's to match up. Yep, gotcha. Thank you. Put that phone away. Thank you. All right. Now can we go ahead and add them and get them to eliminate? Yes, indeed. 12x and negative 12x are going to add together, and they're going to cancel. Yes? Okay. You better go then. 12y and 5y is 17y. Negative 24 and negative 27 is negative 51, I think. Which I hope divides by 17. Is that 3, 51 divided by 17? Well, it'd be negative 3, right? Or is it a decimal? Who's got a calculator? Can you check that for me? Negative 51 divided by 17. I want to say it's negative 3. Okay. Cool. We got our y. We just got to go back and solve for x. So pick either one of the original equations. And I always go into the original equation. I'm not going to use this modified version. In fact, I think I will use the top one. It's got some smaller numbers here. So I'm going to copy that down. 6x plus 6y equals negative 12. But I left out my y because I know what y is. So simplify, let's get this x by itself. Plus 18 on both sides. So 6x equals 6. And then divide by 6 on both sides to get x equals 1. All right, so this is the real elimination. Okay, I kind of started you guys off with some more simple type problems, but this is more of what you're going to see. So can I get you guys to focus on number 2? Look at the x's and the y's. We want to get them to match up. Which one looks easier to get to match up? Can you make a 4x into a 5x easily by multiplying? How about a 4y into an 8y? I think the y's would be easier. What do you want to multiply this bottom equation by so that they would cancel? I'm hearing 2, and 2 is really close to the answer I'm looking for. We're going to modify that 2 just slightly, though. Good. Remember, we want one of these 8y's to be positive and one to be negative. We've already got a positive 8y. So we want the other one, the one that we're making, to be negative. So why don't we multiply it by a negative 2 so that we've got a positive and a negative, then they're going to cancel, right? All right, so let's rewrite our top equation. It did not change at all. The bottom equation is going to change. Everything gets multiplied by negative 2. And I just made my favorite mistake. Once you write down that second equation, can you look up at the screen and tell me what did I just do wrong here? Yeah, I didn't multiply this last one, did I? Did anybody else make that same mistake? I'm seeing a few people erase. It looks like a few people did. That's okay. You made it once, you made it now. Just keep an eye out for that. It is such an easy mistake to make. This should not be a 4 here. Negative 2 times 4, it should have been a negative 8. All right, we're set up to eliminate now, folks. Let's go ahead and do it. So negative 10x and 4x is it's negative 6x. Our y's are going to cancel because we got a positive 8 and a negative 8. Over here, when we add these together, we're going to get negative 24. Let's see if we can get that 6 by itself. We're going to divide by, get the x by itself. We're going to divide by negative 6 on both sides. We'll get x equals negative over negative will be positive. 24 divided by 6 is 4. We still need our y. I'm going to go back and choose one of these. The bottom one's got smaller numbers. I think I'll go with that one. 5x plus 4y equals 4, except I left my x out because I know what x is. And then we'll solve that to get y. All right. So what I'd love for you guys to do is practice this a little bit. I want you to at least get the next two problems done. Does anybody have any questions about these two examples that we just did? Let's pause here for a second. Before you go on, can I get you guys to look up here really quickly? I want you to just do the first step for each of these four problems. Let's practice just doing that. What I mean by that is, I want you to just choose one of your equations and multiply it by something to get one of the variables to eliminate. Now, in this first one, this is an interesting one because I'd say I could eliminate the x's or the y's pretty easily. If I wanted to eliminate the x's, what would I multiply this 3x by? Multiplying by 2 would get me a 6x, which would cancel with the negative 6x. That would totally work, wouldn't it? If I wanted to eliminate the y's, what would I multiply this negative 1y by? By 3. By negative 3, that would turn it into a positive 3, which would eliminate. So you've got your choice here. You can do one or the other. I'm going to probably get rid of my x's in this one. So I'm going to multiply this top one times 2. Oops, I almost made a mistake there. And then my x's are going to cancel. I just want you to do that first step for all four of these, please. Just that first step. Just where you're multiplying one equation or the other by something and then just canceling. And then you can come back after you've done that and do the rest of your work. So take a moment right now and just do that first step for these four problems. Let's make sure we're all on the same page here. And then we can practice the other piece.